Let's complete one sample problem. You need to fill in the chart for each quadratic equation. You're going to begin by identifying the values of a, b, and c. So that would be 2, -3, and 7 because the quadratic equation is already in standard form. Next, you are asked to find the value of the discriminant. Remember, it's equal to the radicand, b squared minus 4ac. So you will fill in b, which is -3, a is 2, c is 7, and do the algebra. -3 squared is +9, minus 56 is -47. Since I have a negative value, that means there will be two complex solutions, meaning your answer will have an I involved. Can the equation be solved by factoring? This is no. Remember, can only be solved by factoring when the radicand ends up being a perfect square. Something like 0, 1, 3, 4, not 3, 4, 9, 16, 25, etc. Now let's actually solve it. Notice all radicands must be, or all radicals must be simplified, no decimals. So I'm going to do this using the quadratic equation. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And I substitute. The opposite of b would be 3 plus or minus the square root of the radicand. I already know it's -47. I'm not doing it all over again. All over 2 times a is 2. Let's simplify. This gives me 3 plus or minus the square root of -47. Well, I can bring out an I. 47 is prime, so I can't do a factor tree. All over 4. This is the exact answer. It is also acceptable to split this into two separate ones where I'd have 3/4 plus 1/4 I times the square root of 47, or 3/4 minus 1/4 I times the square root of 47.